All right, welcome back to another beautiful day of geometry. Today's date is Thursday, September 5th, 2019. If you did that math correctly, yes, we do have a Friday the 13th coming up here this month. Today we are talking about parallel and transversal lines. Raise your hand. Have you heard of transversal lines before?
Yes.
Transversal lines?
Kind of.
Raise your hand if you could explain what transversal lines are to the entire class. Not a one of us. Cool. So we are going to go ahead and learn. All right. Objective. Who can read the objective? It looks like Jessica knows how to read. Go for it.
What? No way.
Use properties of parallel and transversal lines to solve equations.
Yeah, so it's another one of those days of here's this geometry thing, become a master of it, and then apply algebra from last year to it. All right, I see a bunch of people that have answers ready to go because they're not questions, right? All right, so parallel, lines that are the same distance from each other and always something. Jose, never touch. They will never touch. Yeah, you can go all the way out to infinity and they will still be the same distance apart. Okay, what is a transversal line? And Gunnar, gave Jose the 50 XP, right?
Yeah.
Thank you. Transversal, a line that does what to those parallel lines? Go for it, Gunnar.
Crosses?
Yeah, we'll say crosses. I like that word, crosses. Intersects is the more technical term that I would have liked, so I'll give Andres the 50 XP as well. I like intersects. That is the preferred term, intersect. Crosses is the kindergarten term, and intersect is the geometry. How old are you now? You're like 16, the 16-year-old term. You're not 14, are you? You're 14? Wait.
I'm 12.
Really?
This month.
This is a. Oh wait, I don't want to pull that information for YouTube. But anyway, I have a log of exactly how old everyone is. All right, let's label these things. The blue up here. I mean, obviously you have black and white, but my blue. Those are called my parallel lines. Label them. Parallel lines. This one right there and this one right here. There is a way to denote, a way to mark that these are parallel lines. The way that you do that is by doing this little arrow. You just need one, and that lets you know that they're parallel lines. But often on Khan Academy, they like just adding another one just because whatever. As long as they have the same number of little pinnacles, I think they're called. It depends on which way they're facing. Maybe there's something else. As long as they have the same number, those are parallel. For example, if I had another pair of parallel lines this way, I would have one each. If I had two each, that wouldn't make sense. Those are clearly not parallel to those two. So if they had one each, that makes sense. Is that, we're okay with that? Hopefully we're okay with that. All right, and then obviously the red one is the transversal. That's the one that intersects the parallel lines. That is the transversal. The transversal, there's nothing special on that line to denote that it's a transversal, just the fact that it goes across the parallel lines. You're supposed to be able to interpret it just like that. So far, so good, just the vocab. Let's talk about alternate interior angles. Alternate interior angles are always, what's the mathematical word for equal, but in geometry? Equal was for those simpletons in algebra. Now we're in geometry. We have a new term that means equal to, but for geometry type things. Starts with a C. Julian. It is indeed congruent. Write it down, congruent. Gunner's keeping track of the XP, thank you. Congruent is the same thing as equal to, but it's talking about it's talking about shapes, geometrical things. All right, so if I'm talking about alternate interior angles, this is something that you are going to have to memorize. If I say, what's that thing? You will say alternate interior angles. These are alternate interior angles. Mark them. This angle and this angle are congruent. Again, the inside here is congruent. What letter does that look like? Quiet raised hand. What letter? Josie. It is indeed a Z. Josie got the 50 XP gun. Give Mr. Sindel the XP. Yeah, so if you ever see the inside parts of a Z, know that those are congruent. And I can give you a mini proof too why those are congruent, but these, therefore, are also congruent on the other side. It's as if I took that Z and I stretched it out so the Z was like broken, but you can kind of see that this shape right here is kind of like a broken Z that I pulled apart. That also is technically alternate interior angles.
Wouldn't a Z be, if you would like pull it apart, wouldn't it just be straight?
I mean, all the way it would be a straight line, yeah. I'm assuming that I always have two parallel lines with a transversal. If I pulled it apart, I still have alternate interior angles for the red. That's the only thing that you need to know for today. How to know which angles are congruent by alternate interior angles. Nod your heads. We're okay. We can understand alternate interior angles. Normally, I would confuse you with a ton of theorems on day one. I'm just going to go with one at a time. So, and here's your hint when solving the following problems. All problems dealing with parallel and transversal lines, oh, that's all of today's lesson, Mr. Sindel, will have angles that are either, there's only two possibilities. One of them is a word that I've already talked about in the last two fill in the blanks. Quiet raised hand. Andres. Starts with a C. It is. Congruent. You will always either have congruent angles or, what is the term that we learned yesterday when I have an angle here and an angle here on a straight line? Oh, there's a term for that that starts with an S from yesterday. Quiet raised hand. Who has it? Oh, Jenny, yeah. I mean, you're not wrong. I'll write it down. So give her the XP. Straight. I was looking for a different term, though, that starts with an SU. But Jenny, that was awesome. I was totally unexpected, and that is 100% correct. If two angles add up to 180 degrees, by definition, that is called Josie. Oh, man, Josie with the terms today. Killing it. Good job, Josie. It is indeed supplementary. I can't write. Supplementary. Because it makes that straight angle, the straight angle of 180 degrees. So, those are your two options. Congruent, that means what? Equal. Thank you, Andres. And again, yell it out. Supplementary means it adds up to?
180 degrees.
That means something plus something equals 180. Those are your only two possibilities. When you're setting up your equations, which you're not going to do until you go to the back side of the notes, when you're setting up your equation will have one of two possibilities. Equation 1 is equal to equation 2, or equation 1 plus equation 2 is equal to 180. I'll say that again. It's important. It's the only two possibilities. Angle 1 is equal to angle 2, or angle 1 plus angle 2 is equal to 180. Only two possibilities. Let's move on to some easy examples. And you have to use alternate interior angles for your answer, your verbal answer. You don't need to write down alternate interior angles. You'll say, this is congruent to this by alternate interior angles. So, I need to figure out what the angle of X is. I mean, I can kind of eyeball it and be like, oh, I think it's about this many degrees, but you need to prove it using alternate interior angles. So, I will do this left-hand side, you will do the right-hand side. There's two things that you need to know. Alternate interior angles and vertical angles. Vertical angles are, shout it out. Vertical angles are, shout it out. Andres got it right the last time. Congruent. Everyone is going to shout congruent. Vertical angles are. I'm going to throw something at you. Vertical angles are. I have tenure now. I can get away with it maybe. I don't know. Yeah, give everyone 10 XP. That was a procedure right there. So if I had, it's just a procedure. If you have vertical angles, know that you have the same measure for the angle. All right, so I'm going to move, and you can choose to move whatever you want. I can choose to move the X, or I can choose to move the 80, the angle. I'm always going to choose the number because I'm just going to be consistent. I'm going to move the 80 over here. Why? Why am I allowed to say that this angle and this angle are both 80 degrees? Why am I allowed to say that? Quiet raise hand. I told you what you're going to have to use. You have one of two things, two theorems. One of those two you're going to be using. Is there anyone new? No, Gunnar, you've participated. Jose. Fernando, yeah. You're going like this. Call me. Call on me. Oh, yeah. Jose, go for it. There it is. Thank you. Give him the 50 XP. Alternate interior angles. Those are the inside part of the Z. You don't have to draw this, but you can see that there's a Z right here. Does everyone see it? The inside of that Z, that means alternate interior angles. That's why Mr. Sindel is allowed to say this angle is 80 degrees. It is congruent to this angle by alternate interior angles. So everyone, right now, label in your notes, this is 80 degrees. If you want to know why, if you're taking really nice notes, you would say this is true by alternate interior angles. And you can abbreviate now because that's kind of a handful to write. You can say alternate interior angles, or angle singular. I guess it's plural because it's two angles that we're talking about. All right. Well, now I have a question. Can I somehow move? Is there a teacher error? Can I somehow move 80 degrees onto X? Okay. If you say yes, is there a quiet raised hand that can tell me why I'm allowed to do that by one of those two theorems? It's either vertical angles or alternate interior angles. Why am I allowed to move 80 degrees to right here? The same people over and over again. Andres.
Because it's vertical.
Because it's vertical angles, exactly. This angle, 80 degrees, and this angle, 80 degrees, they go through straight lines. That's opposite. 80 is opposite of the X. Therefore, 80 can be moved on top of the X. Well, if 80 and X are the same angle, then X is therefore equal to 80 degrees. And I'm writing this down, but by the end of the homework tonight, you should just be able to do this in your head. You should, without writing anything, you say, okay, 80 degrees, boom, that goes here by alternate interior angles, and that goes here by vertical angles. Done. X is 80. Done. It's that fast. You need to be able to move easily between alternate interior angles and vertical angles by tonight. That is the goal. And then also use equations to actually do some solving. All right, so what you're going to do with you and whoever's around you is use vertical angles. Maybe you want to jump from here to here, then alternate interior angles, jump somewhere else, then vertical angles, jump again. Somehow jump so you get as close as possible to Y, and then you'll tell me they're either supplementary or they're congruent. You have two possibilities. So again, I will repeat. You have two possibilities for your answer. They're supplementary or they're congruent, and you're using two possible theorems. Vertical angles or alternate interior angles to jump around. So, jump around. Figure out 120, where does 120 move? Start moving right now with people around you. All right, so we're back. There are a lot of good jumping, but a lot of people still need to work on what theorems you're using. Again, I will write down the two possible theorems. If you forgot the theorems, maybe you should write them down too. The two theorems from tonight are 1, vertical angles. Whenever you do a jump from this angle to this angle, that is vertical angles. Whenever you do alternate interior angles, that's jumping on the inside of the Z as long as you have parallel lines. Those are the only two things that you're doing. So whenever you make a jump from one angle to another, you need to have a reason. Geometry is all about proofs. I'm introducing proofs as this very informal idea of make sure you have a reason for why you jump. If you don't have a reason, I will throw it out. A lot of you had reasons that said, well, this angle kind of, or maybe this small angle looks like that small angle, and you're right, but you need to be more formal. You need to have an explanation. So, is there someone that wants to come up to the board and tell me what their jumps were and why? Sergio. Undivided attention to Sergio.
No, one is this one is right here because it's vertical angle, right?
Yep, vertical angle. So far, so good.
And then this one goes to this because it's interior, alternate interior.
Perfect.
And this one because it's vertical.
Perfect. Yeah. So this angle right here is the same as all of these angles. This angle right here is 120 degrees. Perfect, Sergio. And what's your last step? Oh.
This one is 60.
How'd you get 60? You're correct.
180 minus 120.
Yeah, what are these two angles called? Two angles that add up to 180? They're called... There it is. Perfect. Good job, Sergio. Yes. So, Gunnar, can you please give Sergio his 50 XP? Again, making sure that everyone understands how to get there. I want to make sure that everyone understands what we're doing right now. We jump from here to here by, shout it out.
Vertical angle.
We jump from here to here by,
Perpendicular. Extra.
Alternate interior.
we're going to say it again. We jump from here to here by, alternate interior angles. Say it on 3. 1, 2, 3. Again, alternate interior angles. 1, 2, 3.
Is that class procedure, Mr. Sindo?
Yeah, that's a 10 next week.
Whoa.
From here to here. I went from here to here by,
Vertical angle.
again, I went from here to here by,
Vertical angle.
good.
Is that class procedure again?
Another cross procedure. You can keep track of it, yeah. All right, we got to here. We didn't even actually need to get to here because if I got to here, ignore the right-hand side. Ignore the right-hand side. These two angles just right here and here, they both are on a line. If two angles add up to 180 degrees, they're called, starts with S.
Supplementary.
If two angles are on a line and add up to 180 degrees, they're called.
Supplementary.
All right, so they're supplementary, so I can do 180 minus 120 to get 60 degrees. Make sure you really have this down because we're about to get harder. Now instead of just giving you X's and Y's and making it very clear that big is not small, I'm going to make it so that this line is almost 90 degrees so you can't tell with your eyeballs anymore unless you have really good eyeballs. Are you guys ready? Again, it's really easy to see that obviously this is small and this is big, but I'm going to make it harder and with variables. Here we go. Hold on to your shoes. Here we go. Now it's a little bit harder. You can't immediately say A is equal to B. You can't immediately say A is equal to B or maybe A plus B is equal to 180. Now we have to use our rules to jump around so we don't make a mistake. Let's do this one together. All right, here we go. Where should we go first? Where should we go first? Vertical angles. Let's do vertical angles. Boom, we're there. These two are the same. They're vertical angles. Alternate interior. Top left. I'm going alternate interior here and here. These are the same angles. And then finally, vertical angles will say that this angle and this angle are the same. Therefore, B and A are the same angle because we did vertical angles, alternate interior angles, vertical angles. There are two people that got XP there.
Me. Undress and undress.
I think that's my HP. So I'm Justin Julian.
Yes. All right, again, let's repeat the process. We went from A to this angle by, everyone's going to shout it out. We went from A to this angle by, and then we went from this angle to our next angle by, perfect. And then from this angle to angle B by, there it is. Vertical angles. All right, so that's like 40 XP for all of the procedures there, Gunnar, if you can catch them. I know, fast fingers, fast fingers. All right, so that means A and B are, there's a C word that I'm looking for. A and B are, shout it out. Looks like it starts with a C. C, congruent. A and B are, A and B are congruent.
I already knew from the start they were.
Okay. So, if A and B are congruent, set their measures, set their angles equal to each other. I'm going to say now that 4x plus 109 is equal to the red angle 2x plus 101. And then I'm going to solve for x. When I solve for x, is that what I'm looking for? What is the question asking for? Is it asking for x?
Yes.
Is it also asking for something else?
Yes.
Okay, so we do need to solve for x, and then we're going to do another step on top of that. Quiet raised hand. First step, solving equations. Back to Algebra 1. Preferably someone new. Andres, Gunnar, and Jose have been participating like crazy. They're getting lots of XP.
I need to keep that.
Sergio and Fernando have participated by, those are my backups. Is there someone brand new, brand shiny new who hasn't participated today? What is the first step? Help your neighbors. What is your first step? All right, Fernando.
Minus 2x on both sides.
All right, everyone write it down. We're going to subtract 2x on both sides. That 2x is no longer there. Fernando, read our new line.
2x plus 109 equals 101.
There it is. All right, thank you, Gunnar, for getting Fernando's 50 XP.
Wait, that's not too
What do you mean?
Proximo, next step. What am I doing? Please, someone new. All right, I'm laying down the law. I'm cold calling on someone unless someone new speaks up. I'm cold calling. People that I could possibly cold call on. Eder, Montse, Cohen.
Cohen, that's 60 XP.
60 XP.
You three, one of you three needs to participate right now.
Cohen, that's 60 XP.
Although Jenny hasn't participated really that much either.
Cohen, 60 XP. Cohen, I'll give you.
Yes, Montse, thank you.
You subtract 1.
Wait, did you say 101 or 109? Perfect. Yeah, 109 from both sides. Read our new line, Montse. Equals negative what? It is negative 8. Yeah, there it is. Good job. All right. Montse got her XP. Thank you, Gunnar. And our final step in terms of solving this equation. We'll call in old people again. It's okay. Yeah, Sergio.
Divided by 2
Divide it by 2. X is
equals -4.
negative 4. Am I done? Do I box my answer?
No.
No. What am I going to do next? Andres.
You plug it into A.
Plug it into A because I'm finding A. A. All right, so it's going to be 4 times what, Andres?
So it's gonna be 4 times -4.
All right, I'll pause. All we're doing is we're rewriting A, but instead of X, we're writing negative 4 because this negative 4 down here got plugged in right there. All right.
So it would be 0 plus 109, right?
Would it?
Yes. It would. Because 4 times -4 is a.
What's-
Oh wait, never mind.
Okay, tell us what it is then.
It's -16.
It is indeed negative 16. So down here we have a negative 16 plus 109. All right, Gunnar, did you get Andres' XP? Thank you.
It's double.
Jose, finish us off.
So it would be 93, right?
You didn't get
Negative, say again?
It would be 93.
-16.
93. 93 degrees, box it.
Boy,
All right. And it does look to be about 93. It's a little bit bigger, so that makes sense. Box your answer. We did a lot of work. It's kind of hard. Was the answer negative 4? Was the answer 109? It was 93. And don't forget your units, 93 degrees. You guys are going to try example number 3. It's going to be a little bit harder. I think I'll let you guys do the first few steps. First of all, figure out if A is equal to B, if A is congruent to B, or if A is supplementary to B if I have to add those two angles to get 280. It's one of those two options. Go now. Good luck. All right, question, Andres.
So how can I gain HP?
You can gain HP if someone heals you. If you heal yourself, that's it. All right, so solving for X, I'm going to run through this problem, then I can answer more questions. This angle and this angle are equivalent by quiet raised hand. These are XP. Jessica. All right, that's 50 XP to Jessica. It is indeed vertical angles. And then this angle and this angle are congruent by what theorem? Josie. It is another 50 XP to Josie for alternate interior angles. And you could go further if you want, but you don't need to. These two angles are on the line. This line right here. Anything that's on a line always adds up to quiet raised hand, and the term that's called. We'll give it to Josie again. Josie.
180 supplementary.
Oh man, Josie, you're just killing it today. It is indeed 180 degrees supplementary angles. So that means that this angle, which is A, and this angle B add up to 180 degrees. That means these two add up to 180 degrees. The way that we say that in algebra is we write it all out. We say that 4x plus 17, that one angle, plus the other angle, which is in red, plus 3x plus 23. Those two angles add up to 180 degrees. All right, from here, I need to combine like terms on the left-hand side. Whenever you're on one side of the equal sign, that means you're combining like terms for these expressions. Is there anyone that can combine the like terms on the left-hand side, both the variable and the constants? Monse, yeah. 7x plus 40 is indeed correct. That's set equal to 180 degrees. Monse got her 50 XP. Gunner's tapping away like crazy over there because you're going so fast. The next step is to do what to both sides with a quiet raised hand. Lots of XP being given out today, Andres.
Minus 40 on both sides.
And our new equation will then read, Andres.
7x equals 140.
140. Okay, our last step after Andres gets his 50 XP, Jenny.
With 7x by both sides.
And you get x is equal to 20. All right, are we done, Jenny? We are not. All right, so who has the next step? Monse. Yeah, this 20 is being subbed in right there, so it's going to be, I'll rewrite it out. 3 times that 20 plus 23. Thank you, Monse. I need a final volunteer to reduce this into one number. Sergio.
So 3 plus 20, 10, 20, 60.
Perfect, and 83 degrees. There it is. Final answer is 83 degrees. Lots of work everywhere. Not the neatest work, but there it is. I know that you guys are working on Khan Academy because you move so fast, but give me a fist of 5 for our objective today. Use properties of parallel and transversal lines to solve problems. I see a 4, a 5, a 4, a 5, a 5, a 6, a 5, a 4, a 4, a 10, a 4. Okay, so obviously if you got a 6 or a 10, you can never make any more mistakes because you are now perfect, right?
Yes.
I want you to make mistakes, though. Get to an 11. I need you to improve. Make mistakes. Get better. Improve. That's the end of the